Okay, what we get is delta t then is, well, if we use distance 2L over cosine theta at speed v, we'll be dividing this distance by v, and we're going to get 2L over v cosine theta. If we use Vx equals v cosine theta, then, well, in the x direction it's moving at this speed, and it moves 2L. So it moves distance 2L at speed v cosine theta, and the time is again 2L divided by that speed v cosine theta. Now, we want to calculate the change in the momentum. So we observe that the initial momentum could be written, if we introduce an I and a j, as pi plus equals p parallel I plus p perpendicular j. And then what's pf? Well, what happens? You observed it. The j component doesn't change. It just keeps moving because the wall exerts no force in the direction perpendicular or parallel to the wall, only in the direction perpendicular. It can only change the velocity perpendicular to the wall, it can only change the momentum perpendicular to the wall, and it reverses that. Speed stays the same, so you could write it like this. Okay? The upshot of that then is the change in momentum is, well, if you subtract this from this, you get negative p parallel I, and the j components go away. So you get negative 2p parallel I. So the magnitude of delta p is 2 times the magnitude of p parallel. And p parallel, of course, is and I left out my mass, I'm going to have to sneak it in here, 2 times the mass times the magnitude of the velocity. Okay? So, and that is just 2mv cosine theta, because the angle between here and here is always between negative 90 degrees and positive 90 degrees. Okay, so we have this so that the magnitude of the average force is what? You get it?
Yes.
Well, you divide this by this, and there this cosine goes into the numerator, as I tried to do too early, right?
It's the same thing, but it's v cosine squared theta.
Yeah.
The last one.
So it's going to be mv squared cosine squared theta divided by L, which is double the average kinetic energy. Well, we don't have an average kinetic energy because right now we just have one particle. So same thing we got before, the times the cosine squared of theta. Okay? Now, the next question we want to answer is, what if the direction of the particle is completely random? In other words, theta can be any angle with equal probability. Okay? Now I'm going to kind of go through that one for you.